Hello, welcome to the lesson video notes for 11.3 over sector area and arc length. Today we are going to be finding the area of sectors and finding arc length. We'll talk about that a little more in depth. We're going to go ahead and skip the warm-up for now just so we can get started with the rest of our video. But we will talk about some of those concepts from the warm-up in the rest of our lesson. Okay, so first let's talk about what a sector is. This is one of your new vocabulary terms. The area of a sector we will look at in just a minute, but a sector is a region bounded by two radii of the circle and their intercepted arc. An intercepted arc, you'll recall, is an arc that is bounded by these 2 points of this angle. So the intercepted arc AB and these two radii make this sector. Think of the sector as being a slice of pizza or a piece of pie. That is what we're talking about, and that is a region, and so it has an area. And here's what the area of a sector is. It's a fraction of the entire circle's area. So what we can do is use our pi r squared, area of a circle, and that fraction breaks down into that angle measure out of 360. So this is our formula for finding sector area. We use that angle measure or arc measurement, these are the same thing, out of 360. That gives us our fraction of the total area, so we take our area times pi r squared. Here's a helpful hint, writing the degree symbol after m in the formula to help you remember to use degree measures, not the arc length. And we'll talk about arc length later on in this lesson, but the degree measure is what we're using for area. So, let's take a look. Example 1, we need to find the area of each of these sectors. We are given the angle JGH as 131 degrees. That means the arc measurement is also 131 degrees. And the radius is 12. So our formula, pi r squared times m degrees out of 360 degrees. Let's fill in what we know. The radius is 12. And our angle measure is 131. Now, we are told to write our answers in terms of pi and round it to the nearest tenth. So what we do here is we do 12 squared times this fraction, and then we write it times pi. But then we're also going to multiply by pi and round that to the nearest hundredth. All right, and here's what we get. I'm going to write it as the fraction 262 over 5 pi when we do 12 squared times 131 divided by 360. This is the fraction we get to reduce. If you actually divide that out and don't write it as a fraction, you would have gotten 52.4 pi, and you can write it that way because we don't have to round. But then we need to take that and multiply it by pi. We're going to do that and multiply by pi, and we should get that our approximate answer is 164.62 square meters. Remember, we're in area of a sector, so we're talking square meters for our unit of measure. Alright, so we've got part B, and you need to find the area of sector ABC. That's this region here. This is the angle measure you're going to use. This is the radius. I want you to use this formula. And go ahead and work that out and check your answer. You'll need to work this out. When you have an answer ready, you can continue watching the video to see what you get, but otherwise you'll have to pause the video so you have time to work. Alright, this is what we should get. Alright, we should get 125 over 72 pi, and here's how we get that. If I do 5 squared times 25 and divide by 360, that fraction reduces to 125 over 72. Before you divide by 360, you want to try and reduce the fraction to write it in terms of pi. But then when we multiply by pi, we get about 5.45 square feet. Alright, let's take a look at our second example. We've got a windshield wiper blade, which is 18 inches long. To the nearest square inch, what is the area covered by the blade as it rotates through an angle of 122 degrees? Well, here's what we have. If I have a windshield wiper blade that rotates through an angle of 122 degrees, the wiper blade does not become any longer, so these are congruent, and we said it's 18 inches long. So you'll notice I get a portion of a circular pattern. This is forming a sector. And so what we need to do now is find the area of that sector. Well, we have a radius of 18 and an arc measure, or the central angle measure, of 122 degrees. So now we plug it, 18 inches. We plug that information into this formula. Which would be pi times 18 squared times 122 over 360. And we can find our area. Now they ask for this to the nearest square inch, so we're going to round to the nearest whole number. I want you to go ahead and do that calculation. Pause the video if you need more time. When you are ready, click play, and this is the answer that we should get. Approximately 345 square inches for the area of that sector. Alright, let's take a look at the next part of our notes, and that's what we call a segment of a circle. Here's your definition of a segment of a circle. It's a region bounded by an arc and its chord. So it's like we're going to cut the crust off of our pizza in a straight line like this. Not making another curved cut, but just cutting straight from corner to corner. This is a chord, and the intercepted arc, okay, that area between those is what we call the segment of a circle. So in order to find that area, we follow this pattern. The area of the segment of a circle is equal to the area of the sector minus the area of that triangular region. We're going to take that triangular region away from this whole sector area, and we get that as our leftover. So that's what we get to do in this example. Now we have to remember how to find the area of a triangle, so I'm going to remind you of that formula. Area of a triangle is 1/2 base times height. Okay, so we'll need to know the height of the triangle, need to know the base edge of the triangle, and so on and so forth. So here's what we have. We have a 120 degree arc, so M is 120 degrees, and the radius is 9 centimeters, so we can find our sector area really easily. Area of our sector is pi times 9 squared times 120 over 360. But that needs to have the area of a triangle taken away from it. The area of 1/2 of our base times our height. Well, we need to find those measurements. This angle is also 120 degrees. So it's not a right triangle, so I can't use the radius as the base and the height. If it was a right triangle, I could do that. What we need to do, and I'll even turn it around so you can see, is think of this as the base, making this the height. So I need to find those two measurements. Well, if this is 120 degrees, half of that is 60 degrees. And if it's a right triangle, then that is 30 degrees. That makes it a 30, 60, 90 triangle. Now, the hypotenuse of a 30, 60, 90, you'll remember, is twice the shorter leg. So I know this segment now. It's half of 9. Don't get confused. That's an upside down 9, not a 6. So this is 4.5. Then the long leg is 4.5 times root 3. So I already know the height of my triangle is 4.5. The base of my triangle is 4.5 root 3 times 2. So that whole base is 9 root 3. Now I'm going to turn this around. The base of our triangle, we said, was 9 root 3. The height of a triangle was 4.5. And so that's how I find my triangle area. So I'm going to reduce all this as far as I can. We have 27 pi minus 20.25 root 3, and when I reduce that and round to the nearest hundredth, we get about 49.75 square centimeters. Remember this, that in a 30, 60, 90 triangle, the length of the leg that's opposite the 60 degree angle, so the longer leg, is root 3 times the length of the shorter leg. Also remember that the hypotenuse is twice the length of the shorter leg. Now, let's move on to talking about arc length. Arc length is different than arc measure. The measure of an arc is in degrees. The length of an arc is a linear measurement. It's if I could cut this part of the circle, stretch it out into a flat segment, that length is what I'm measuring. Length is always a distance, and so we measure it in linear units like feet, inches, miles. Okay? Now, since the area of a sector was a fraction of the area of a circle, we can think of the arc length as a fraction of the circumference of the circle. So the arc length here is a fraction of our circumference. The circumference of a circle, remember, is 2 pi r. So we take our arc measure in degrees, divide it by 360 to get that fraction, then multiply by circumference, 2 pi r. So let's take a look at example 4. In example 4, we have a given arc FG with a measure of 134 degrees. And the radius of the circle is 8 centimeters. Now, there's no real good reason why 8 centimeters is drawn here and not here. This is also 8 centimeters. Okay, but it's this arc that we are taking the measurement of. So we know the radius is 8. We know the arc measure is 134, so we just plug those into this formula. Arc length equals 2 pi times our radius times m degrees out of 360. So we fill in what we know. 2 pi times 8 times 134 degrees out of 360 degrees. And when you reduce all that, we can write our answer in terms of pi. Again, write it as a reduced fraction times pi. And then we can round that to the nearest hundredth. So why don't you do those calculations, pause the video if you need more time, and when you are ready, click play, and we should get the following answer. 268 over 45 pi, when we reduce this fraction, you do 2 times 8, that's 16, times 134 divided by 360, we get this reduced fraction, times pi, centimeters, not square centimeters because we're doing a length measurement. But when we round that to the nearest hundredth, we get about 18.71 centimeters. Alright, on part B, we can do the same thing even if we're not given the picture. They'll still give you the most important information. We have an arc with a measure of 62 degrees. That's what m is. In a circle with a given radius of 2 meters. Well, now we have enough information to plug into this formula. Why don't you plug in the information, work out your solution, write it in terms of pi, a reduced fraction times pi, then also round to the nearest hundredth. Pause the video so you have enough time to do this, and when you are ready, push play, and you should get the following results. 31 over 45 pi is our reduced fraction. When you multiply all these out and reduce the fraction, we get 31 over 45 pi. And then when we multiply by pi, we get about 2.16. Alright, that concludes our examples for Lesson 11.3. Again, if you have any trouble with this, go ahead and send me a message or ask in class, and I'm sure we can get those questions answered. If you would like to go ahead and begin the Lesson 11.3 worksheet, it is attached to this post. Otherwise, good luck, and if you have any questions again, please contact me.